Hello again. This is our last video for section 3.4. What we're going to do in this video is continue to work with quadratic equations. And the first example or exercise we're going to look at is finding the x and y intercepts of a quadratic equation. So if you remember how to find the x-intercept in the last chapter, we set y equals 0. Well, it's still going to be true even with parabolas because wherever it crosses the x-axis, we know the y equals 0 no matter what the equation is. And similarly, to find the y-intercept, we set x equals 0. So let's go ahead and do that. Let's find the x-intercept first. So to find the x-intercept, we know we set y equals 0, so let's go ahead and do that. And now we have lots of practice solving these. You can try factoring. You can try the quadratic equation. You can try completing the square. What I usually go for first is I see if I can factor it very easily. And then if I can factor it, great. If I can't, I usually go for the quadratic formula. But this one does factor. 5 and 2, right? This is the first. This is the last. 5 and 2 multiplied to 10. And it adds to -3 if I make the 5 negative and the 2 positive. So you can see here we're going to have two solutions. X equals 5 if you add 5 to both sides, or subtract 2 from both sides the second one, you'll get -2. Those are the two x-intercepts. Or you can call them as ordered pairs. So it would be 5, 0, because we know that's when the y is 0, or -2, 0 is the 2 points for the x-intercepts. So now let's do the y-intercept. You know the y-intercept is when x is 0, so I'm going to take my equation and plug in x is 0. Everywhere there is an x, I'm going to plug in a 0, and I get -10. Or you can write this as the point 0, -10. If you graph this on your calculator, let's see if we get these points. Let's go ahead and do that. Let's bring up the calculator. I'm going to type in y equals, if you remember that's how we graph, I'm going to type in our equation, x squared minus 3x minus 10. And I'm just going to go to zoom my standard window, 6. Let's see, we have a -2, 1, 2. Go to trace. First of all, we get 0, -10. It's a little bit below. We can look at that. Maybe go to window. Actually, if we want to look a little lower, we could go to window. Maybe make that y min, maybe -15. I'll leave everything else alone just so we can see a little bit lower. And now I'm going to go to trace. You can see 0, -10 is right there. And this point is -1, -2. That's that x-intercept. And the other x-intercept, 1, 2, 3, 4, 5. You can go to trace and look at those points as well. So we actually can graph this very easily, right? -2, 5, maybe -10 down here, 2, 4, 6, 8, 10. That's a point. That's a point. So these are the two x-intercepts. That's the y-intercept. And you can have a nice little graph. So now you go ahead and try part B. Find the x and y intercepts. Pause it, come back, and then you can see the solution. So again, we plugged in y equals 0 to find the x-intercept. I went ahead and divided everything by 3, and I noticed this does not factor. 2 factors of 10 that add up to 6 does not work. So I'm going to do what we did in our last video, and I am going to use the quadratic formula. Again, you always write down the quadratic formula first. And then what is the A? The A is 1, the B is 6, and the C is -10. So if you go ahead and do this, what do we get? Let's go ahead and do this one together. You get -6 plus or minus. 6 squared is 36. Minus 4, A is 1, so that really doesn't matter. You can write it, you don't have to. Times C is 6. Oh, no, that was B. C is -10. All over 2 times 1, which is just 2. So that's going to be -6 plus or minus. We're going to have here, let's go to the left a little bit, 36 plus 40. So x is going to equal -6 plus or minus, looks like 76. And if you try to take the square root of 76 on your calculator, it's going to be a decimal. So you could get that decimal, or you can leave it as is. Those are the x-intercepts. See, I ran out of room for the y-intercept. Let's see, let's make this a little smaller. Maybe do it down here. The y-intercept is when x is 0. So if I go back to my original and plug a 0 everywhere there's an x, you get the answer -30. So this is the x-intercept, y-intercept. The first one's the x-intercept. If they asked for a decimal approximation, you can find this. So again, what you would do is you would take -6 plus square root of 76 over 2 on your calculator. And then you could take -6 minus the square root of 76 all in your calculator. When you plug this in the calculator, make sure you put this in parentheses because it's all of it. Remember, the all over the fraction sign means that there's imaginary parentheses there. And if you get these two decimals, what I got was approximately 1.36, and if you did the second one, again, making sure you put this in parentheses, -7.36. I rounded to 2 decimal places. Again, you do not have to do that because it just said solve, find the x-intercept, so this would be a fine answer. But if they did ask for approximations, or if you wanted to look at your calculator, you can look at these. So now we know that the y-intercept is like -30. So let's count by tens there. And the x, so that's the y-intercept. The x-intercept is somewhere between 1 and 2 is one of them, 1.36. And the other one, 2, 3, 4, 5, 6, 7, 8. Somewhere between 7 and 8. So 1, 2, 3, 4, that's -4. 5, 6, 7, 8, that's -8. So maybe somewhere here. And so the graph is probably going to look something like that. You could graph that and check it out and see if that's a graph. You would have to change your zoom to make sure that you hit something right, -40. So if you want to see that, you can go to y equals again. We can type in our function. I'm just going to go to graph because that has my last window there. You can see it's terrible. Right, I can't see that bottom thing. So I'm just going to go to window instead of going to zoom. I'm going to change, I don't know why those changed there. Let's go to zoom 6. Because I didn't realize that it did change. Still terrible. So go to window. I'm going to change that y min maybe negative 50, negative 40. I'm going to try negative 50. That's all I'm going to change. Oops, what happened to it? There it is. That's all I'm going to change. And so I'm going to go to graph now. Oh, it's still a little bit lower. But if you go to trace, you can see that point there. And this one's I just counted by 1, so that would be the 1.6. And 1, 2, 3, 4, 5, 6, 7, between the 7 and the negative 8. We did an example on this on the previous video, but you can try this. Use the discriminant to say whether the equation has 2, 1, or no solutions. Pause, and then I will just show you the solution when you come back. If you remember, what's the discriminant? Discriminant is b squared minus 4ac. It's inside the quadratic formula. So if I just look at that, the a we know is 2, the b we know is 7, and the c is 3. If I just plug that in, we get 49 b squared minus 4a is 2, c is 3. 8 times 3 is 24. We can see that this is 25. It's positive. So there's 2 solutions. When this is positive, you're going to have your plus or minus. So you're going to have your 2 solutions. What about part B? Again, if you haven't done it, pause it, come back. The answer is 1 solution. Why? Because I took b squared minus 4ac, and where a is 4, b is 4, and c is 1. I plugged that all in. I got 16 minus 16, which is 0. If you remember 0, this whole term would be 0. You would lose the plus or minus, so you would just have 1 solution. Here's a challenge. A garden wishes to double the area of her 4 feet by 6 feet rectangular garden. Let's make this a little bigger. She wishes to add a strip of uniform width to all 4 sides. How wide should the strip be? This is a challenge problem. You can see if you can try it. And then come back and you can see the solution. So if you're not sure where to start, I'm going to start by drawing a picture. So I'm just going to, Gardner wishes to double the area of her 4 by 6 foot rectangular garden. So I decided to draw a little rectangle and label one of them 6 feet and the other 4 feet. The area of this triangle is 24 feet. So let's just put that in there. Feet squared, actually. 6 times 4. We know that the area is the length times width, which is 6 times 4, which is 24 feet squared. Okay, so she wants to double this. Maybe I will erase this here. She wants to double it by adding a strip of uniform to all sides. So you'll see that we're going to end up with a larger rectangle. So I added X. Notice how I added the same to all 4 sides to make it a larger rectangle. I'm going to use the same formula, area equals length times width, but now she wants to double the area, so that's going to be 48. And the length is going to be something different. It's going to be now 6, and we're going to add, there's an X here and an X here, so we have 2 X's. And the same thing, add that. So the length now is going to be a new length, and the width is going to be this expression, and then I'm going to solve this equation. Here's how I solved it. First, we expanded the right side, subtracted 48 to get a 0 and combined like terms, divided everything by 4, because I noticed 4 was common, ended up with this equation. Factorable, got 2 answers. X is -6, which negative number does not make sense. So the answer is 1. You add 1 feet to all sides.